Good morning, good morning, good morning, good morning, all. Good morning, my dear friends. How are you? Let me know if everything is fine from my end. My dear friends, let me know if everything is fine from my end. How are you? So let's just drop a yes if you can hear me, you can see me, and everything is fine, my dear friends. Just let me know if everything is fine. Yes, yes, yes. So I can already see some comments, my dear friend. Jay, Prashad, Mohammed, very good morning. My dear friends, my name is Sourav and I welcome you all to the live session from the Gate Academy. My dear friends, I hope you are taking care of your health, you are in good health, and you are also taking care of your exam. My dear friends, Gate is in a few days' time. And what is the need of the hour? The need of the hour is revision, right? So everyone is revising or not? Let me know in the comment. Everyone is revising, or you guys are just thinking about the results, that what is going to happen, means useless thinking. Are you guys revising or not? Let me know. Okay. My dear friends, let me tell you one thing, that see, this time, this 10 days time is so crucial for you. Why? Because if you utilize this time properly, you can gain 5-6 marks just based on this 5-6 days revision. Now suppose a student was about to get, let's say, 70 marks, he can get 75 marks, 76 marks. A student who was supposed to get 60 marks, he might get 65, 66 marks. A student who was supposed to get 45 marks, he can cross the 50 barrier, and a student who was supposed to get, let's say, in his 20s, he can qualify the examination. So my dear friends, this revision session or this 10 day period session, you can benefit a lot, right? So never ever stop your preparation. Never think that we generally think that whatever we have done, it's done, now nothing can happen. This is the greatest tendency of the students, right or no? Let me know, yes or no. So my dear friends, based on that thinking, based on that perspective, we are coming with this series. In fact, I'm going to teach you for the next 10 days all the important concepts of your subject engineering maths, which covers 13 marks. 13 marks it is covering. And next 10 days, 1.5 hours a day, we are going to revise all the important concepts in a beautiful manner. No tough problems. All the basic problems I am going to take, but new problems as well. I'm going to revise your concepts around that problem. Means first we are going to discuss the problem, and then we are going to discuss all the related concepts around that problem. So you will realize that when this series is over, all the important concepts have been beautifully revised without any strain on your mind. So my dear friends, let me know who you are there or not. You are there or not? So I can already see some comments. Yes, everyone is agreeing with me. And Jui, Lakshmi, Mohammed, very good. Rajdeep, yes, very good, very good. So my dear friends, let me tell you what is what we are going to discuss today. So you can see on the screen that it is what, day 1 differential calculus. My dear friends, today I am going to discuss, see, when you say calculus, what do you think? Polynomials, limits, continuity, differentiability, application of derivatives, increasing, decreasing function, maxima, minima, all those concepts, Taylor series, Maclaurin series, then integration. Mainly our today's topics will be these, and from tomorrow different topic, day after tomorrow different topic, and so on and on, right? So my dear friends, without wasting any time, I'm straight away going to start the session. and meanwhile you can also ask your conceptual doubts if you have any, and I'll be teaching you, no issue with it. Let's start my dear friends. So just drop a yes that if you are ready. Just I want you just take a pen, a paper, sit down. Calculator also you might take, it will help you. So just let me know if you are fine to start with the session, my dear friends. Just drop a yes. Just drop a yes that yes sir, we are ready for the session. And my dear friends, let me tell you that if possible, you can share it with your friend circle so that they can also come here and enjoy the session. They can revise their session. Yes. So let's start. My dear friends, I hope you are sitting with your pen paper, right? My dear friends, if you can see on the screen, this is the first question that I have, I'm presenting to you. Read the question once. Read the question once. Read the question once. The question is talking about a polynomial has been given and it is asking that means it will have all real roots, a real or complex root, real, complex, how much real, how much complex, and this is the question. My dear friends, such questions have been coming in the past. Yes, such random questions are coming in the past. So let us quickly discuss this basic question. My dear friends, if a polynomial is there of nth degree, it will have some real roots and it will have some complex root. This is the first thing. And the summation of the roots is going to equal to its degree. Yes or no? Now we have some special methods which addresses this problem, like for finding out the real and complex root. The name of such concept is Descartes method. Descartes method. Now, some of you will be hearing it for the first time, Descartes method. So I'm not going to discuss it, right? Because it's a new method. I'm not going to put any additional burden on your brain. If you guys want, I can teach you till means by the end of the session. That's another thing. But suppose we don't know that theorem, then what we can do for checking out the roots? What we can do? Anyone? Any idea, my dear friends? Anyone in the comment? What we can do in this problem? Any suggestion? Any suggestion? What we can do in this problem? My dear friends, differentiation is a great tool that we have. Always keep in mind, differentiation is a very good tool that we have got in mathematics. Let's differentiate. Now, my dear friends, when I differentiate the function, I'm getting 5x to the power 4 plus 1. Now, for any x, this thing is always greater than 0. Yes or no? For any x, this thing is always greater than 0. That means always positive. And when f dash x is always positive, can I infer from it that the function is strictly increasing? Yes or no? When f dash x is always positive, I can say that when it is strictly increasing, that means the function is going up and up and up and up and up and up like this. Yes or no? When it is strictly increasing, the function is always increasing. That means it is always going up and up and up and up and up. Yes or no? So my dear friends, if a function is always going up, never coming down, so it will intersect the x-axis how many times? Tell me in the comment section. If a function is always going up, it is going to intersect the x-axis how many times? In the comment section. When a function is always going up, it is going to intersect the x-axis how many times? One. Very good, very good. Once when a function is always going up, it is going to intersect the x-axis at least one time. Now one time it is going to intersect, and that is the thing. Now my dear friends, when a function is intersecting the x-axis at one time, that is equal to the number of real roots, right? It is intersecting the x-axis. Suppose here is the x-axis and it is intersecting one time, then that is equal to the number of real root. Now my dear friends, total number of roots is 5. Number of real root is 1. Number of real root is what? 1. So how many complex root will be there, my dear friends? If the number of real root is 1, total number of root is 5. So number of complex root will be 5 minus 1, 4. So the answer is what? 1. So the answer is what? 1 real and 4 complex. This is one thing. This is one method, and I am sure that everyone has got this method. That problem is solved fine. Now my dear friends, I am going to discuss another method over here. When it comes to finding the roots, graphs are always going to be helpful. Just keep this thing in mind, right? Now graphs means what? Now suppose that I write x square minus 5x plus 6 is equal to 0. If I ask you how many roots are there, you will quickly solve this using the middle term and tell me that sir, x equal to 2 and 3 will be the answer. Fine. Graphically, how we can see? Graphically, if we try to plot this equation, it will be something like this. Roughly I am drawing. That means it is intersecting the x-axis how many times? 2 times. That's why number of solutions was 2 for this equation. My dear friends, what we can do in this question? The function is x to the power 5 plus x plus 2. Now you will say that sir, here the polynomial was very easy. You are very easily drawn it. So fine. What we can do over here? X to the power 5 plus x plus 1 is equal to 0, because you will tell me that sir, plotting this polynomial is not easy. So my dear friends, I am going to construct our LHS and RHS in such a way that the plotting will become easy. Now see my dear friends, I am going to write x to the power 5 is equal to minus of x plus 1. This is my LHS, this is my RHS, and I am going to plot it. Now my dear friends, can we plot x to the power 5? Can we plot x to the power 5? My dear friends, if it will look like x cube graph, if plotting x to the power 5 will look like x cube graph, and it will be something like this. Everyone agrees it will come under the basic graph only. Can we plot minus of x plus 1? My dear friends, if you plot minus of x plus 1, it will look something like this. See, if you plot minus of x plus 1, it will look something like this. Now see my dear friends, how many points of intersections are there? How many points of intersections are there? Only one. So my dear friends, in graph, the number of points of intersection of two graphs gives you the number of real solutions. So how many points of intersection are there? 1. So number of real solution will be what? 1. And if number of real solution is 1, number of complex solution will be 4. My dear friends, is it clear or not? Tell me. Tell me the graphical method is clear or not? Tell me my dear friends, the graphical method is clear or not? Is it clear? That clear everyone? So see, we discussed two methods related to this question. Now my dear friends, the first one was Descartes method, the second one was differentiation method, the third one was graphical method. My dear friends, there is one more method which we call intermediate value theorem method, but we will discuss it after some time. So just keep in mind that if I want to conclude, Yes, very good, Joey. First one was easy and quick. Second one also is very good only. Just keep in mind that we have this much of methods available to us, and whenever a question comes for finding the roots or finding the real roots, complex roots, we have got 4 or 5 methods, and I'm going to apply any one of the method for solving the question, right? So, my dear, I hope this question is clear to everyone. And my dear friends, I'm quickly going to move on to the next question, my dear friends. Rupesh has asked a good question, sir. For complex, how can we determine? Rupesh, all this method is for real. So total number of degree, if you subtract it from degree, it will give you the number of complex root. Got it or not? Rupesh, if you subtract it from n degree, you are n minus 1. So you are going to get the complex one. Clear, Rupesh? Now everyone just see this question. Just see this question, everyone. My dear friends, this is a question of limit, as we can see over here. Got it, sir. So before solving this question, can anyone tell me what is the indeterminate form of this limit before I start solving this question? Can anyone tell me the indeterminate form, which is means for the limit? What is the indeterminate form? What is the indeterminate? 1 to the power infinity. Very good, Shreya. It is 1 to the power infinity. My dear friends, for any exponential form, you might have studied that close your eyes and start by taking log on both the sides. That is the go-to method for any exponential indeterminate form. Let me solve this question. So just assume that y is equal to limit x tending to 0 a to the power x plus b to the power x plus c to the power x by 3, and it is to the power 1 by x. My dear friends, now since my friend told that, sir, it is 1 to the power infinity form, so just quickly take log on both the sides. Quickly take log on both the sides. It is for go-to method for any exponential indeterminate form. So just follow what I'm doing. So if I take log, it will be, yes or no? Log a to the power b, b log a. Now 1 by x comes over here, and I am putting this 1 by x in the denominator. Now my dear friends, what was the purpose of taking log? Nothing. It is only converting your exponential indeterminate form to either 0 by 0 or infinity by infinity. Now after taking the log, you can easily see that the question has been converted into a 0 by 0 exponent, 0 by 0 form, and everyone knows that 0 by 0 or infinity by infinity, the method that we have is L'Hopital's method. So my dear friends, the numerator is 0, denominator is 0. Quickly apply L'Hopital's rule. L'Hopital's rule is what? Differentiating the numerator and denominator, right? So my dear friends, let's differentiate it. So denominator differentiation is 1. I'm not going to worry about that. So log x is 1 by x multiplied by, by chain rule, I am going to, do the differentiation. A to the power x into log a plus b to the power x into log b plus c to the power x into log c. Now this 3 and this 3 gets cancelled out, and it is limit x tending to 0, a to the power x log a plus b to the power x log b plus c to the power x log c whole divided by a to the power x plus b to the power x plus c to the power x. My dear friends, if you put 0 in this limit, after doing, we have to put the limit na. If you put 0, it will be what? 1 by 3 in the denominator, and it will be log a plus log b plus log c, which you can write collectively as ABC. My dear friends, if you just simplify it, log y is equal to log ABC to the power 1 by 3, and if you just equate it, you are going to get y is equal to what? ABC to the power 1 by 3. Yes or no? ABC to the power 1 by 3. ABC to the power 1 by 3. ABC to the power 1 by 3. I hope the calculation is clear, and the answer is ABC to the power 1 by 3. Everyone got it or not? Everyone got the concept and the solution or not? Let me know. Just drop a yes sir, got it. Everyone clear with the solution? Yes. My dear friends, so what did we learn in this question? We learned that any exponential indeterminate form, we are going to take log on both sides. Now, quick questions for every one of you. Can any one of you tell me how many exponential indeterminate form we have studied in limit? The total number of exponential indeterminate form that we have studied in limit. Can anyone tell me the number in the comment section? Just a quick basic question. Mohammed, you are telling the total number of forms. I am asking you only the exponential form. You are telling me the total number of forms. I am asking you the exponential form. My dear friends, we studied, let me tell you, we studied 3 exponential indeterminate forms in our limit. 3, very good. Aryan, very good. We studied 3, which is 0 to the power 0, infinity to the power 0, and 1 to the power infinity. These 3 exponential indeterminate forms we have studied in limit, and anywhere you get exponential form, you should remember that the first job is taking log on both the sides. Now, my dear friends, see its applications. You can see a question that a very basic question that is in front of you. Can you tell me what is the form of this limit? Can you tell me what is the form of this limit? Just tell me the form. No need of just doing the problem. Just tell me the form. Very good, Muhammad. Very good answers. It is infinity to the power 0. I am putting over here infinity and e to the power 0. Infinity 1 by e to the power 0. It is nothing but infinity to the power 0. E to the power minus infinity, 1 by e to the power 1 by infinity is 0. Infinity to the power 0. My dear friends, you know how to start the question. By taking log on both the sides. No need of doing the question. I am just asking you that how we are going to start the problem, because once we know how to start the problem, half the battle is won. Fine. Can you tell me what is the form of this limit? The next question. Can you tell me what is the form over here? Same, no issue, no headache. Just know the form and know how to approach. Very good. Same, infinity to the power 0, and you know how to proceed with the solution, taking log on both the sides. My dear friend, not only this, even if any differentiation comes, that's our differentiating power to the power function to the power function, function to the power function, anywhere you get, just you know that you have to take log on both the sides and start the problem. Now see, I'm so much stressing on the starting the question, because half of us or half of the students are confused in the starting only. They don't know how to start. Not only this, even if a question comes in maxima and minima, that sir, find the maximum value of this, where you have function to the power function, the only method is taking log on both the sides. Just remember that. Now I'm so much stressing on this. And my dear friends, not only in calculus, in complex number also, if you get a question like, find the value of I to the power I to the power log I to the power I, anything, you know that you have to start the question by taking log on both the sides. So what general method we have discussed? The general method is we get power to the power to the power means function to the power function. We are going to start with taking log on both the sides. My dear friends, sorry for stressing this much, but is it clear? The entire thing, the entire concept number 2 is clear, my dear friends. Is it clear, my dear friend? Just tell me yes, sir. Proceed to the next question. Yes. Very good. Excellent. So my dear friends, here is the third question. For you. And it is from continuity and differentiability. Read the question once nicely. Read the question. Function has been given x mod x, the set of points where fx is twice differentiable. Rupesh has asked a question that, sir, why we are relying on L'Hopital? My dear Rupesh, we have 3-4 methods for dealing with problems of 0 by 0 form. Right? We have rationalization method, we have factorization method, we have binomial expansion method, and we have L'Hopital's method. But 99% of the question is going to be solved by L'Hopital's method. 99% of the question, just keep in mind, right? Not only 0 by 0, infinity by infinity also. Just keep this in mind, right? Anywhere we are able to apply L'Hopital's rule. That's why it's a go-to method, the famous method. Okay, so let's come to this method, this question. My dear friends, a function has been given to you, x mod x, and it is asking that a set of points where fx is twice differentiable. My dear friends, before starting, everyone has read the question, I assume. My dear friends, let me tell you that anywhere you see mod, first try to remove the mod and then do anything with the problem. This is the basic thing that I am telling you. Now anywhere means anywhere, be it differentiation, be it integration, or be it in limits, continuity, differentiability, remove the mod sign. Now sir, how to remove the mod sign? Do we know this thing, that mod x is equal to x? for x greater than equal to 0 and mod x is equal to minus x for x less than 0. Yes, it's a basic definition of mod. Using this definition, remove mod sign first, and once we remove it, we are converting from composite function to simple function, and we are able to deal with simple functions very smoothly. Composite functions means what? Made up of two functions. So if I apply this property, the function has become what? X square. Now see, x square for x greater than equal to 0 and x square for x greater than equal to 0 and minus x square for x less than 0. Yes or no? Now we have converted it in a simple function and now we are able to deal with the function very smoothly. Now it is asking you the function is twice differentiable. Now keep this thing in mind, twice differentiable. Twice it is asking you. So let's check about this function. Let's check about this function. My dear friends, you put 0 in this function, you put 0 in this function and we are getting 0. That means what? LHL is equal to RHL. No, for differentiability we have to first check continuity na. So LHL is equal to RHL. Fine. Now I am differentiating the function and I am getting 2x for x greater than equal to 0 and minus 2x for x less than 0. My dear friends, why did I do that? Because you have two options. Either use left means the differentiability criteria in your main function or use the continuity criteria in your f dash x function. Both is going to yield you the same answer. I repeat, you must have studied that for differentiability LHT is equal to RHT. Left hand differentiability is equal to right hand differentiability. So either you use that criteria in your main function fx or you use the continuity criteria LHL RHL in your f dash x function. Always keep this thing in mind. They both are going to give you the same result. So I differentiated the function and when I put 0 in this function, I am going to get the same answer 0. That means what can I say? I can say two things. First, f dash x is continuous, or this is equivalent to saying fx is differentiable. So this is a very important concept that everyone should note, that saying fx is differentiable is equivalent to what? Saying f dash x is continuous. So first thing is clear that fx is differentiable everywhere, no issue. Now let's check the second because the question is asking you about twice differentiable. So I again differentiate it. I am getting 2 for x greater than equal to 0 and minus 2 for x less than 0. My dear friends, at 0 means greater than 0, it is giving me 2. Less than 0, it is giving me minus 2. Are they two equal? No, my dear friends, they are not equal. That means what? F dash x is differentiable. F dash x is differentiable at all. F dash x is differentiable at all the points except what? X is equal to 0. At x equal to 0, it is not giving me the same answer. One is giving me 2, one is giving me minus 2. Clear or not, my dear friends? So what will be your answer? Your answer will be that it is fx is twice differentiable at all the points, that means real number, except at 0. So what becomes your answer? Your answer becomes r minus 0. My dear friends, again I will tell you, can we use the graphical method to understand this question much better? See, I can also refer the graphical method. How? Just see quickly, 1 minute time. It will hardly take a minute of time. See. My dear friends, see, this is what? This is the graph of x square. This is what? This is the graph of minus x square. So the function was telling you what? X square for x greater than equal to 0 and minus x square for x less than 0. So I'm going to do that only. For greater than 0, I'm going to keep the blue part, and for less than 0, I'm going to keep the black part, right? So see, I'll do a magic and this thing disappears, right? For greater than equal to 0, the blue part, less than 0, the black part. Now tell me, my dear friends, is this graph a smooth and the curves are there in the graph? Yes, it's a smooth, continuous, differentiable graph. And we know now that if a function is smoothly drawn, no sharp turnings in the graph, it will be continuous and differentiable. So for once, fx is continuous and differentiable everywhere. Fine. Let's plot the second one. Let's plot the second one. Now second one was what? Tell me. It was 2x. It was 2x and minus 2x. Yes or no? So see, my dear friends, 2x will look like this. The full 2x will look like this, and minus 2x will look like what? Minus 2x will look like this thing. So for greater than 0, I'm going to keep the blue part. For less than 0, I'm going to keep the black part. Done. So it is 2x for x greater than equal to 0 minus 2x for x less than 0. So my dear friends, you can see now that exactly at x equal to 0, we are having a sharp turning. And whenever we have sharp turning, my dear friends, a function is not differentiable. Yes or no? At any sharp turning, the function is not differentiable. So that is why it was not differentiable at x equal to 0. Clear or not? My dear friends, it is clear or not? Tell me. Clear or not? The two methods, both the methods, clear or not, everyone? Both the methods. See, we are discussing so many multiple methods of dealing a question. It is developing. You are developing an all-round concept for solving a question, right? My dear friends, but what was the most important learning from this question? The most important learning was, whenever you have mod sign in any function and the question is asking you to differentiate, integrate, finding limits, continuity, differentiability, anything, the first job is removing the mod sign, taking out the mod sign. Remove the mod sign by using the basic definition, my dear friend. That is what I'm stressing. I'm stressing on the basic points. Please note it somewhere. Please note it somewhere. See, suppose I have given a question to you. See, here is the second question based on this. We are not going to solve it, but I just want that the first step should be clear in your mind. Can you tell me in the comment section what you will do in the the starting step? Just can you tell me what is your prime objective in this question first before differentiating? Remove mod. Very good. Remove mod. Remove mod. Remove mod. Very good. Very good. Very good. No, Mohammed, see, f double dash x, you saw na that at x equal to 0, these two were not equal. The slopes were not equal. That means what? At x equal to 0, this f dash x is not differentiable, or the main function is not twice differentiable. Yes, na? See, the slopes were coming out to be unequal. And see, check over here. In in this f dash x graph at 0 the slopes are not equal na. This right hand side the slope is 2, left hand side the slope is -2. At x equal to 0, sharp turning है ना. Sharp turning the graph is never differentiable. Mohammed, sharp turning graph is never differentiable. Got it na? Right? Chalo. So let's move on to our next question. And my dear friends, this is the question of the day. This is the question of the day. If you just solve this question, entire application of derivatives is covered in this. Just read the question once. If you manage to solve this question, your entire application of derivatives will be covered in this question. Just read this question once. I'm going to give you some time. I'm not going to hurry that quickly we have to discuss the question. Just read it nicely for 1 minute. Just read it. My dear friends, for any in application of derivatives, what is the main thing that we do for any question? Can anyone tell me? In application of derivatives, what is the first thing that we do? We differentiate the function. As simple as that. In application of derivatives, we differentiate the function and then we do whatever the question asks us to do. Yes or no? So my dear friends, quickly I am going to differentiate the function. My dear friends, there is a method, there is a formula called Leibniz method. There is a formula called Leibniz method. Which deals with integration, which deals with questions of integration under differentiation sign. So if I use Leibniz method over here, that means if I differentiate the function, the integration sign will be removed. And what we have to do, we have to just put the functions x in place of t. We have to put the function x in place of t. Multiplied by differentiation of the function, which is 1, minus you put 0 everywhere, multiply by its differentiation, which is going to be 0. So I'm not going to write that, or let me write also, it's not going to be a problem. And I want to find the stationary points, that's why I'm equating it to 0. That means all in all, if I differentiate it and equate it to 0, can anyone tell me the stationary points, my dear friends? Can anyone tell me in the comment section that what will be the stationary points for this function? Why did I find a stationary point? Because the question in the options you will find maxima, minima and all the things. Can anyone tell me, my dear friends, what will be the stationary points? Very easy. Yes or no? I am going to get x1 as 2 and x2 as 3. These are the stationary points. So my dear friends, in the options, if you see, it is asking you that 2 is having maxima, local maxima, 3 is having local minima. Can anyone tell me that for maxima and minima, what is the second step? We double differentiate the function. Yes or no? Suppose f dash x is what? E to the power x square into x square minus 5x plus 6, we have, and for checking maxima and minima, what do? We double differentiate, yes or no? So I'm going to double differentiate it. I'm going to double differentiate it. How we will double differentiate? I'm going to consider this as one function and this as the other function. So e to the power x square into differentiation of this is what? 2x minus 5, yes or no, plus the second function multiplied by differentiation of the first, e to the power x square into 2x, yes or no? So it will be e to the power x square and it is what? 2x minus 5 plus, if you just multiply, it will be 2x cube minus 10x square plus 12x. So it will be what? E to the power x square 2x cube minus 10x square plus 14x minus 5. My dear friends, everything is clear till here. I have double differentiated the function. Now what is my job? I am going to put the stationary points in this double differentiated function. So if I am putting it, let's say I am putting 2 over here. Forget e to the power x square, it is always going to give me positive. Just focus on this part. Can anyone tell me? Let me use the calculator over here. Let me see what I am getting. My dear friends, I'm getting minus 1. I'm getting minus 1. E to the power x square is fine. It is always positive. I'm getting minus 1. That means I'm getting negative. I'm getting negative. My dear friends, you must have studied this in your maxima and minima, that if the double differentiation at the stationary point is coming out to be less than 0, that means it's a point of maxima. Yes or no? Yes or no, everyone? You have studied the same thing, na? That if double differentiation is less than 0, it is going to be point of maxima. And let me substitute x equal to 3, my dear friends, over here. So e to the power x square is going to be positive. I am not worried about that. If I put 3 over here, it will be what? Tell me. If I put 3, what will be the answer? If I put 3, it will be what? Anyone? It is going to give me 1. It is going to give me 1. That means what? This is positive. This is 1. This is positive. That means if double dash x is coming out to be greater than 0. So my dear friends, can I conclude that x equal to 3 is a point of minima? Is a point of minima. So x equal to 2 is the point of maxima and x equal to 3 is the point of minima. So can I tick mark these two options? That f has a local maxima at x equal to 2 and f has a local minima as x equal to 3. Till this clear or not? Till this point, is the question clear or not, everyone? Question is not over yet. Question is not over yet. Till this point, everything is clear, my dear friends? Tell me. Very good, very good, very good, very good. Now see, my dear friends. Read option number 2. Option number 2 is saying that f is decreasing on 2, 3. F is decreasing on 2, 3. So we have to do something about that option also. My dear friends, see, I am plotting this curve. I am plotting this wavy curve to check the nature of f dash x function. My dear friends, f dash x function is what? E to the power x square, x minus 2, x minus 3. I want to know the nature of this f dash x function. What is f dash x? I am writing it again. Your f dash x is e to the power x square into x minus 2 and x minus 3. Yes or no? I want to know the nature of this f dash x. Sir, why? Why do we want to know the nature? Because it is asking me increasing, decreasing, where it is giving me positive value, where it is giving me negative value. Fine. So my dear friends, I will plot the stationary point. What are the stationary points? One is 2 and one is 3. And I know the wavy curve method. Now I don't know if you have studied this wavy curve method before or not, but what do we know here? That any value greater than 3 if I put, I am going to get positive, and any value less than 2, not this, any value greater than 3 if I put in this, if I put in over here, I am going to get positive. Now when I come over 3, you see the factor of x minus 3. X minus 3 is having an odd factor 1 over here. So plus becomes minus, minus becomes plus. So the graph will go over like this. Again, if you come at 2, x minus 2 to the power 1, it is having an odd factor. So minus becomes plus, plus becomes minus. My dear friend, this is wavy curve method. This is wavy curve method. All in all, what do I want to know? What do I get from this? I get that from after 3, I put any value over here, I'm going to get positive. Before 2, I put any value, I'm going to get positive. And between 2 and 3, I put any value, I'm going to get negative. This is what I have done over here. This is the wavy curve method. If you want, I can also teach you separately, because not now, because we are doing questions. Now my dear friends, what was the significance? The significance is that we get to know, see, between 2 and 3, f dash x giving you what? Between 2 and 3, f dash x is giving you negative. Between 2, 3, f dash x is negative. Now what does this imply? This implies that if f dash x is negative, that means it is implying what? Tell me. It is implying that fx is decreasing. Fx is decreasing, and that was your option. Very good. That was your option. Yes or no? That f is decreasing on 2, 3. Are you got it or not? Tell me. My dear friends, getting or not? Fx is decreasing on 2, 3. And this I calculated using the wavy curve method, right? So the question could have been this, that from where to where it is positive, from where to where it is positive. So you can easily tell now that from minus infinite to 2 it is positive, and from 3 to infinite it is positive. It can also be, you can also treat it like this. Now my dear friends, we have, very good, yes, correct, we have one more option. We have the options are not yet over. See the beauty of this question. The options are not yet over. Option number 3 is saying that there exists some c value such that f double dash c is equal to 0. My dear friends, here comes the intermediate value theorem that I was talking about in question number 1. What is intermediate value theorem? You are going to get it in few minutes. See, but first read the option again. The option is saying that there exists some c such that f double dash c is 0. Means between c there is some value for which the f double dash x function is going to give you 0 value. That means it is having a root. Now what is the f double dash x function? Quickly see over here. The f double dash x function is this. Now see, I am going to pick up this one. I am going to pick up this one and take it to somewhere else. Let's put it over here. This is the f double dash x function. Now my dear friends, what is the intermediate value theorem? Just see. If I put 0 over here, if I put 0 in this function, I am going to get minus 5 into e to the power x square, which is a negative value. Yes or no? Which is a negative value? Very good. Now I am taking any value of my choice. Let me take 1. Let me take 1. What we are getting if I put 1 over here, e to the power 0 is also 1, sorry. What am I getting if I substitute 1? See, if I put 1, I am getting 2 minus 10 plus 14 minus 5. I am getting 1. I am getting 1 into e to the power 1, which is nothing but e, and e is a positive value. My dear friends, I am putting 0, I am getting negative value. I am putting 1, I am getting positive value. I am putting 0, I am getting negative. I am putting 1, I am getting positive. That means there is one root of the function between 0 and 1. This is your intermediate value theorem, and this theorem is also used for finding the roots of the function. My dear friends, in the first question I told you that there are few methods which is helpful in finding the roots of the function. There is differentiation, there is plotting graph, there is intermediate value theorem also, which we just discussed now. And it is useful whenever interval has been given. Is this clear or not, my dear friends? Is the concept clear or not? Tell me. So option D is also correct. Option D is also correct, my dear friends. That yes, there exists some C for which such that f double dash C is 0. So that means, my dear friend, in this question all the options are correct, and if you can treat it as an MSQ question, so you can, this is the grand MSQ question where all the options are correct. Arey, you are getting or not? No comments. Clear this question. Entire application of derivatives has been covered in this question, my dear friends. Are you there or not? No comments I am seeing. Arey, you are getting the explanation. You are getting the explanation. Entire AOD has been covered in this question. And my dear friends, let me tell you that if you are finding it useful, drop a like and share it with your friends. It will help everyone. Chalo, so see, so beautifully and so smoothly we are covering all the basic concepts of calculus, and this is how we are going to proceed. My purpose is not only to solve a question over here, but to discuss all the related concepts around it, so that the theory portion is also getting revised along with seeing questions, right? So see, last one I told intermediate value theorem. What is intermediate value theorem? Suppose an interval has been given. A function has been given. So put the points of the interval in the function. If one is giving you negative, another is giving you positive, that means there is one root of the function between that value. This is what intermediate value theorem is. As simple as that. So in this, what did we do? This was my main function. This was the main function. Let me use a different color pen. This was the main function. I substituted 0, I got negative. I substituted 1, I got positive. 1 is negative, 1 is positive, 1 is negative, 1 is negative, positive. That means between 0 and 1, what I am getting? That between 0 and 1, there is at least one root. There is at least one root of f double dash x. It means what? One root is there means what? That means if I put that value over here, I am going to get 0. That was asked in the question. Yes or no? This is what? This is called what? This is called intermediate value theorem, intermediate value theorem. It is used for finding the roots of any function. I hope this is clear, Mohammed. I hope now this is clear. Chalo, everyone is happy and everyone is getting the concepts. Chalo, let's do a basic question now. Let's come to a relatively basic question so that the concepts are also getting revised. So for that purpose I have taken a previous year gate question so that the concept is getting revised. Please do it. Please read the question once. Please read the question. A basic question. Just come down. Let's come down a little. Chalo. So my dear friends, if you are reading the question, you will realize that this is a question from partial derivatives, partial differentiation, partial derivatives. My dear friends, you know that when partial derivatives come, there are more than one independent variables, right? In dy by dx, I know that my independent variable is only x. But when I am considering partial derivative, you know that the d sign is going to be replaced by del sign because there are more than one independent variable. So see the question. The question is saying you assume that x and y are independent variable. Now why did I take this problem, my dear friends? The purpose of taking this question was students are generally confused that which are independent, which are independent, which are dependent, which are independent. The confusion is among this only. Like in this question, the question is saying that assume that x and y are independent. Assume that x and y are independent. It means what? It means that this is implying that R and Z are dependent variables, my dear friends. R and Z are dependent variable. Now, sir, why are you stressing on this independent dependent? Because the differentiation of one independent variable with respect to other independent variable is 0. That means wherever dy by dx comes or del y by del x comes, you are going to put it 0. But for z, you are not going to put it 0. Let me solve the question. You will get it eventually. See, the question is giving you what? The question is saying you find the value of del r by del x. Fine. R is what? X square plus y minus z. Very good. So it is asking me del r by del x. See, del r by del x is 2x. Now see, the next term dy by dx will be what? 0. Why? Because y is independent and differentiation of one independent with respect to other is 0. Now z, what we have to do? We have to write del z by del x. Now why did I not write 0 over here? Because z is not independent, z is dependent. That's why I am not allowed to write as 0. This was the only confusion that I felt was needed to be clear out. Fine. This is my one equation. It's very clear, my dear friends, that I need to find this value. Which value? Del z by del x. I need to find this value. Which value? Del z by del x. Now how I'm going to find out? I'm going to use this. So z, just a minute, I'm writing it over here that it is z cube minus xy plus yz plus y cube is equal to 1. This is my second equation. I want to find del z by del x. What I have to do? I have to partially differentiate it with respect to x. So see, 3z square minus y, because y I am considering it as a constant, plus y del z by del x because z is dependent, plus y cube differentiation 0 is equal to 0. Fine. 3z square minus, I am missing a del z by del x over here. I missed a del z by del x over here. Minus plus y del z by del x is equal to y. Again, del z by del x. I want what? Del z by del x. Y by y plus 3z square. So I want del z by del x value, which I am getting as y by y plus 3z square. Yes or no? I am going to substitute this over here. So when I substitute, what I am getting, I am doing it over here only. So see, del r by del x is equal to 2x minus, now you put the value y by y plus 3z square. And my dear friends, what are the values given? The values given are 2 minus 1, 1. 2 minus 1, 1. Now x equal to 2, 2 minus 1, 1. So can you tell me what will be the answer? Can you tell me what will be the final answer? If I substitute 2 into 2, 4 minus plus 1 divided by, it is minus 1 plus 3. So 3 minus 1, 2. And the final answer, my dear friends, anyone? What is the final answer? The final answer is 4.5. Yes or no? The final answer is 4.5. Yes or no? So my dear friends, it's a very basic question, I know, but what was the purpose of discussing? It was only to tell you that in a partial differentiation question, just see that which of the variables are dependent, which of the variables are independent. Now my dear friends, suppose it is not given, you might get a question that it is not given that which are dependent and which are independent. In that case, take x and y as independent variable by default and proceed for the question. Right? Got it na? That suppose in this question it was not given x and y are independent. So in that case, proceed assuming that x and y are independent and just do the question. Don't wait that, don't find that the gate authorities are going to give me dependent or independent. Fine. Enough talk, enough I have said on this question. Let's move on to this one small and cute question on the partial derivatives, which is based on Euler's theorem. This small cute question is based on Euler's theorem, which is also important in this AOD section. Just see this question once. Just see this question once. My dear friends, have you studied Euler's theorem? Do you know Euler's theorem? Just tell me yes, no. You have studied about Euler's theorem, my dear friends? What does Euler's theorem tells you? My dear friends, if u is a homogeneous function, if u is a homogeneous function with the degree is equal to n, then this relation is always satisfied. It's a proven result. It is called Euler's theorem. My dear friends, what is a homogeneous function? A homogeneous function is a function in which the degree of all the terms are same. It is called a homogeneous function. I hope you know this thing. Now, my dear friends, if you consider this function log u, you can see that the degree of its numerator is what? 3. The degree of its denominator is what? 1. Numerator degree is what? 3. Denominator degree is what? 1. So the net degree of this is what? 3 minus 1, which is 2. My dear friends, here log u is homogeneous. Here in the given question, here log u, which is x cube plus y cube by 3x plus 4y. This function is homogeneous. Homogeneous. Now what is the degree of degree is equal to 2. So this is the only confusion that sir, generally u we talk about as homogeneous function, but here log u is homogeneous. How to do in this case? Very simple. Very simple. Just assume this as w. Just assume this log u as a w function. So if w is homogeneous, if w is homogeneous, if w is homogeneous, so according to Euler's theorem, can I write this? Can I write like this? X into del w by del x plus y into del w by del y is equal to nu. N is what? 2. So sorry, nw. nw. What is n? 2. So 2w I am writing. This is as per Euler's theorem. Yes or no? Yes. My dear friends, what is asking? It is asking you x del u by del x. It is not asking w by del x. It is asking you del u by del x. So what do we know? We know that w is equal to log u. So can I find del w by del x? Del w by del x is 1 by u del u by del x. Yes or no? And del u by del y is 1 by u del y by del x. Yes or no, my dear friends? That means I am converting all the w thing into my u thing, because the question is asked in terms of u. Now making all the substitutions over here, if I make all the substitutions over here, what will I get? I am making all the substitutions over here. What will I get? X by u into del u by del x plus y into y by u into del, sorry, I have made a mistake over here. It is del u by del y. I have made a mistake over here. It is del u by del y. Del u by del y is equal to 2. And what is w? W is log u. So my dear friends, what was asked in the question? It is asking you x del u by del x plus y del u by del y, and just take u to this side and it becomes 2u log u. That means this is your final answer, because this was asked na. What is the value of, what is the answer? 2u log u. 2u log u. My dear friends, is it clear or not? Tell me. From that time only I am speaking. You guys are just on the other side of the screen telling nothing. Is the concept clear? Is the concept clear, my dear friends? Tell me. No one is saying anything. No one is saying anything. From that time only I am speaking, and you guys are only sitting on the other side of the screen eating popcorn and telling nothing. No one is saying anything. Clear na, Euler's? Yes. Very good. Yes. Yes, I can see the comment section. Yes, very good. Okay. So my dear friends, So integration I'm not going to touch today. Integration I'll be touching tomorrow. So I have in mind that this question from total derivative might come as a surprise question in GATE. I just feel, I don't know, but that's why I've kept this as a surprise concept. So everyone just check this question once. This question from total derivative, everyone just read once the question. Integration I'll be taking tomorrow. So I just feel that questions from GATE is asking you some random questions, some not so common questions from which generally the question don't come. So that's why I've written surprise concept in this one. Just read it once. Read the question once. If x increases at the rate of 2 centimeter per second at the instant when x equal to 3 and y equal to 1, at what rate y must be changing in order that the function 2xy minus 3x square y shall be neither increasing nor decreasing. Shall be neither increasing nor decreasing. So my dear friends, what is the question saying you? See, here let me assume this as 2xy minus 3x square y as u. Let me assume it this function. Saying that dx by dt, that means x increases at the rate, dx by dt is nothing but plus 2, and here it is asking you dy by dt. It is being asking, the question is asking you. Now see, x and what is total derivative? What is total derivative, my dear friends? You let me assume u is a function of x and y. Let me assume u is a function of x and y, and x is a function of another variable, let's say t, and y is a function of another variable, let's say t. X and y are functions of one variable, let's say t. And the question, if I have to write what is du by dt, what is du by dt, at that time I use the concept of total derivative. I repeat, my dear friend, once again I repeat that u is a function of xy, x and y are functions of some other variable t, and if I have to write du by dt, what I will write? This is in accordance, this is called the concept of total derivative. So there is a formula over here which goes like del u by del x into dx by dt plus del u by del y into dy by dt. This is the formula for total derivative. Now keep in mind the signs that I'm writing, where I'm writing del, where I'm writing d. All these things are important because once a question in GATE has come on just the basic expression of total derivative. Fine. So my dear friends, what we have to find? We have to find del u by del x, we have to find del u by del y, dx by dt is given as plus 2, and dy by dt is we have to find, and it is saying that the function is neither increasing nor decreasing. This u function is neither increasing nor decreasing, that means du by dt is nothing but 0. It is given that u is neither increasing nor decreasing, that means du by dt is given as 0. So my dear friends, I hope that you have got the concept, and now what I'm going to do, I'm going to just simply find all the needfuls. I'm going to simply find all the needfuls, whatever is required. So my dear friends, del u by del x, del u by del x is what? Del u by del x 2y minus 6xy. Yes or no? Del u by del x into dx by dt is what? 2. Dx by dt is what? 2 plus del u by del y. Del u by del y is what? 2x minus 3x square, and dy by dt you have to find. Dy by dt you have to find, and this is given as 0. So we have to find dy by dt. I have done all the thing which is required. Just we have to simplify it. We have to just simplify it. So it will be what? It is 4y minus 12xy plus 2x minus 3x square into dy by dt is equal to 0. Now what are the points given? The points given is x equal to 3, y equal to 1. X equal to 3, y equal to 1. X equal to 3 and y is equal to 1. So it is 4 minus 12 into 3 is 36 plus 2 3 ja 8 minus 3 square 9, 9 3 ja 27 dy by dt is equal to 0. Getting or not, everyone? Getting or not the concepts? Clear or not? So this is minus 32 plus this is minus 20 minus 19 dy by dt is equal to 0. Sorry, I made a mistake. It is 6. Sorry. 6 minus 27 is minus 21. So dy by dt is minus 32 by 21 centimeter per second. So my dear friends, this I feel is a surprise, can be a surprise question, and that's why I have included in my question. Tell me, is the concept and explanation clear or not? My dear friends, is the concept and explanation clear or not, my dear friends? Tell me. No comments from your side. Is the concept of total derivatives clear, Pranjali? Everyone who is watching, is it clear, my dear friends? So my dear friends, what have we discussed today in this 1.5 hours of session? What have we discussed? Now see, just I'm taking you, let me take you through the questions that I have discussed. See, in this 1.5 hours of time, we discussed about polynomials. We saw that what are the methods of solving a polynomial, differentiation, plotting graph, intermediate value theorem. In the second question of limit, what we discussed, that whenever there is an exponential limit, the go-to method is taking log on both the sides and proceed. Now once you take the log, you are brilliant. You are going to do any question after you take log on both sides. That much faith I have on you guys. Third, differentiability, continuity, we discussed it. Very nice, very easy, fine. But what was the main concept? The main concept was, whenever there is mod in the question, let me generalize. Whenever there is a modulus function, whenever there is a greatest integer function, whenever there is a smallest integer function, all these functions are piecewise functions. It will make a function composite. That means made up of two functions. So we cannot do differentiation integration directly. So first we have to remove these composite functions into make them into simple functions and then proceed. This is the main concept in this question. In the fourth question, I discussed you, this fourth question should be the question of the day. Yes or no? I feel that this fourth question is the question of the day, because everything, all the application of derivative part has been included in this. It's a super question, and I request all of you to practice this question in your home, because this is going to clear all the concepts regarding the AOD part. So I'm not going to tell you much about this, because there are so many related methods in this question. And my dear friends, the final question was then I told you about dependent independent variable, and then we discussed about homogeneous function, and finally I discussed with you the concept of partial total derivative. And I thought that this can be a surprise question in GATE this time. So my dear friends, did you enjoy this revision session, and did you like this model of question plus concepts? Tell me, did you enjoy this session? Tell me, did you find any benefit, my dear friends? I tried to complete all the differential calculus concepts within this short 1.5 hours of session. And my dear friends, this is going to continue for the next few days. Today I took differential calculus. Tomorrow I am going to start with integral calculus. My dear friends, integral calculus, all the double integration concepts, all the related multiple integrals concept I am going to take tomorrow. So tomorrow, are you going to join me or not? Tomorrow, are you going to join me or not, my dear friends? Tomorrow, integral calculus 1.5 hours and all the related concepts we are going to discuss. And my dear friends, the least I can ask is share it in your friend circle so they can also come, and hit a like button if you enjoyed it, share it, and just keep on revising, my dear friends. Just keep on revising. And so I'm not going to waste much time. It's 11:30, 1.5 hours of session. Till tomorrow's session, take care. Goodbye. Revise it and revise it, right? So my dear friends, chalo. So I'm ending the session, my dear friends. I'm ending the session. Let's meet tomorrow at 10 with some new concepts. Chalo, I'm ending it. Bye. Goodbye, everyone.